Good day, everyone. My name is Mark Swanson, and I'm the IT storyteller for the NetApp on NetApp team. And welcome to this month's Inform session. I'll be joined by Senior Business Process Analyst Lisa Kurowski, who'll be sharing her knowledge on the value of a robust CMDB. We'll be taking questions in the chat, so please feel free to ask away. And with that, I will turn it over to Lisa.
Thank you, Mark. Welcome, everybody. So as Mark said, we're going to talk a bit about configuration management databases today. My name is Lisa Kurowski. I'm a senior analyst with the NetApp IT Service Management Solutions team. I have a couple of hats at NetApp. I am the process owner in IT for configuration management, but I'm a member of the team that actually supports ServiceNow, so I'm also the product owner. We have a major program within IT for Cloud One, and I provide integration between the ServiceNow and the CMDB to that program also. So we'll talk a little bit about how that integrates in. Okay, you should be able to see my presentation now. So let's talk a little bit about what our agenda is going to be today. And we've got some good transition points between each section, so folks want to put questions into chat. Mark, you can help me as I pause and go between the between the sections. You can give me what the questions are, but we'll have Q&A at the end also. So I wanted to start the presentation as a whole with some summary thoughts on the journey towards CMDB. And then I'll get into what ServiceNow, what IT has done specifically in their implementation of ServiceNow CMDB, and our journey towards laying a basic foundation upon which we were then able to extend and integrate that into many, many different things over the last couple of years. And this is a good talking point for our Cloud One program and how we've been able to leverage the CMDB in our self-service cloud programs. I want to talk a little bit about auditing and data governance. This is actually something that I just stuck into the presentation last night because I realized that's sort of an aspect that was missing. And then I think we're remiss if we don't talk about some of the pitfalls, either mistakes that we've made or challenges that we continue to have with our CMDB. And then the big question, is the journey ever over? So I wanted to start a little bit with some summary thoughts on the CMDB. We've had our CMDB in place now for a good 10 years. And if there's one thing that I can share, because I'm often asked by customers and partners, how can we shortcut this? How can we speed up the process to implement a CMDB? And the primary thing that I say is the challenge with CMDBs is they're very big, right? They're big beasts with a lot of diverse data in them. And there's no way really to speed up and shortcut that. The best thing to do is to prioritize what's important and versus what's nice to have. And to focus on laying a clear foundation, a stack of CMDB data that serves as your foundation, and then expand and mature iteratively from there. Because the bottom line is that it's going to take a while to implement a broad CMDB that covers all the different kinds of assets that you might have in your IT organization. The other thing is really to look at the whole CI lifecycle. And ITIL tells us that configuration management, we should focus on how do we instantiate new assets in our environment, and so how will they become represented in our CMDB? What is the life cycle of those? How are we going to maintain those? And then what is the end of life? And it's really easy. Often have people come and say, let's add this to the CMDB. And let's just put it in. Let's tick off a box and let's get that data in there so we could show management that we're making progress. And the problem is that if you really don't think about that whole life cycle, I can guarantee you from experience that data will begin to grow stale, and you'll immediately have a challenge with the reputation of your CMDB as soon as there's a pocket of data that is inconsistent, incomplete, or inaccurate. People will tend to say, well, the CMDB itself is not useful. And so it's really important before you agree to begin dumping data into your CMDB that you do think about the entire life cycle. You think about standards, you think about data ownership. And one thing that I will confess that we did forget was about retirement. You're often so excited about getting the data in there, and you do figure out how you're going to manage it. You kind of figure out, you kind of forget sometimes about how does these assets exit our environment? Do we know when they exit the environment? And how are we going to track that? So I would encourage you, before you get too excited about starting to dump data into the CMDB, that you do take some time to think about the standards and the data ownership and how you're going to maintain and sunset that data, so that you don't end up with stale data that folks look at and then don't want to use the CMDB. And the last talking point is something that may seem really obvious, but it's really important to have this core component of maturity in the CMDB before you try to start integrating it with things. But the reverse is also true. We'll talk a little bit about IT's journey and where we started and when we decided to begin integrating the CMDB into things. But often I'm engaged by folks from the storage side. They want to integrate their data into the CMDB, and there's a great path to get that data in the CMDB. But if the core CMDB, particularly the data related to logical servers and applications and how they fit together, isn't mature, pushing your storage data into the CMDB is probably not going to provide you the benefit that you need, because you need to have a strong central component stack of data in your CMDB to tie into before adding your storage data is really going to be useful. Concurrently, if you want to tie your CMDB data into incident and change management, but those are weak processes, you'll find that having a strong CMDB but weak incident and change management processes is still not going to get you to where you were really hoping to be. So let's talk a little bit about how NetApp IT implemented their CMDB. And this is a bit of an eye chart. This is a capability map for ServiceNow, because our initial initiation with ServiceNow was in an ITIL transformation program, where we were looking at maturing our incident, change, and problem management processes. And then we built a self-service employee portal for our stakeholders to be able to reach out to IT. So around that time, IT decided to build a new production data center and consolidate all of our infrastructure there. It became apparent that our homegrown CMDB was simply not going to support it. And extending into the ServiceNow CMDB and leveraging discovery met a couple of the key things that we needed to implement for CMDB that helped fix some of the problems that we had with our original homegrown. Our original homegrown CMDB was primarily used by data center services, so it was really great at capturing this data down here in the physical layer. Equipment and data center things are easy to go out, and because you can physically look at them, they're easy to inventory. But our CMDB kind of unraveled as you moved up the stack. It was really incomplete with the logical data. It was not well accessed either, which is a key challenge that the data center services team had access to this. The operations team had sparse access to the CMDB. And of course, the data was sparse, it was incomplete, and it wasn't being well managed. And when you moved up to the top of the stack, application teams and DBA teams had no access to it. Most of them didn't even know it existed. So moving to ServiceNow's CMDB met a couple of key points in being able to consolidate that data in an arena where everybody would have access to it. A couple of our other key objectives were to implement as much automation and self-service as we could. So even from the inception, with a narrow focus on let's put our really good data in for data center services, and let's focus on this portion right here. We're going to focus on our Linux, Windows, Solaris, we had AIX, and our hypervisors. Let's have that stack be very, very clear and its tie points up to the applications. Let's have that stack of data be very concise. Let's have it be very accurate, and let's implement as much automation as we can. So we implemented probe discovery to help us maintain the data here in this green logical infrastructure layer. And we implemented a self-service. So there was a self-service portal on top of the equipment layer that allows data center services to initiate hardware provisioning for any new piece of equipment that they get in, with the advantage being that as soon as they begin that hardware provisioning, the CI for that data is in the CMDB then, from the inception of that order through that piece of equipment being useful. And the same thing here, of course, we had a program where we needed to lift and shift out of existing data centers into this new production data center. So we built a catalog to be able to provision these logical servers. And from the moment that order is placed through the point where I can kick off discovery in a single, concise line of automation, that CI is in the CMDB, tied down to the equipment and tied up to the application where they wanted to order it. So one of our objectives that we've kept in place all along is to try to avoid as much manual management of data as we can. Currently, our data center, our CMDB, covers both on-prem traditional data centers. We have private clouds, and we're ever expanding into the public cloud arena. You can kind of see the basic size of our CMDB. It has 270 classes, but realistically, most users are going to sit in the use of maybe 50 or 60 classes of data, but you can get sort of a general size. We have probably around 6,000 servers in our infrastructure, with about 1,000 of those being in the cloud. So the cloud presence is ever increasing. This is a diagram that I put together probably just a couple of months after I joined NetApp. The CMDB had been in place for about 6 months, but it wasn't in use yet by the general IT population. It was primarily being used by data center services to manage and build up that production data center. And it was being used by the design architects who were building the new production servers that they were spinning up in the new data center. And I put this diagram together for my own use, and then I've used it in training ever since, because it really helps people understand the complexity of the CMDB, but in a way that they can understand if I'm accessing data here, where does that put me in the CMDB? But it also allowed us to sort of focus on our core competency for the data. So our initial focus, and this is one of the things I always recommend, is choose something that you're going to mature, and mature it really well. And from there, you can then expand to add in other things. So for us, it was the application data tied to the logical infrastructure, tied to the core of the equipment or physical architecture, tied down into the data center. And this chart also helped me with other things, because data ownership, understanding life cycle of the data and how the data is going to get pulled together. If you're not familiar with ServiceNow, each box basically represents a class, except that I clubbed a couple together in this box, and every line represents a relationship. And it's having those relationships that really makes it a configuration management database. Otherwise, you have a large inventory of lots of different things, but the objective is to understand how the data pulls together so that you can understand the direct dependencies. This host is running on this blade, and the indirect dependencies, right? That this application is impacted by problems down in the lower architecture. For our data architecture, this lower layer of data is primarily manually managed. It's pretty stable. We don't make a lot of changes to the data centers, although we do represent the public cloud here in the data center tables also. And I'll tell you a little bit about why we go ahead and put the public clouds in there, even though it's clearly not going to have zones and computer rooms. But we've tied our discovery into info blocks. Info blocks gets annotated with what data center are these subnets associated with. So whether or not the computer room and data center are in the cloud, or whether or not they're in the private cloud, or whether or not they're on-prem, we go ahead and we have entries in the CMDB that tie this data back to locations. And then I can use that data to annotate info blocks. When I run my discovery schedules, they look at the subnets that we obtained from info blocks. Those have annotations that tie back to our CMDB and allow us to then annotate the location of any CI that we discover. So subnet A is a part of this computer room, which ties back to a particular location. Then anything that I discover in that subnet is going to be annotated with that same location. So this helps us with that automation component where we don't want to have to manually touch our data. This data is pretty stable. It's touched manually and owned by data center services. As we move up a layer, this data is also owned by data center services, but it's a little bit less manually managed because it's front-ended with the service catalog that lets them do hardware provisioning. So of course, it's not actually automating the hardware provisioning. It's a service catalog that itemizes the steps that are required to get from unboxing a piece of equipment to the point where that piece of equipment is active and ready for use. And since the service catalog sits on top of the CMDB, it ensures that the data goes into the CMDB with consistency. It uses ServiceNow's model catalog, and these CIs are instantiated in the CMDB from the moment that they begin that hardware provisioning process. So when we move up a layer, really this is where probably 90% of the data in the CMDB resides. We do leverage ServiceNow's discovery. That allows us to populate this data and keep it maintained. We do have a couple of different service catalogs that sit on top of it. We have our original rudimentary catalog that we built way back in the beginning while we needed to spin up new production VMs for that new data center quite quickly. Again, it sits on the product catalog model database so that this data has consistency. And that catalog was integrated with discovery. So you place the order, provision the VM, hit it with discovery, and it's all tied in. For virtual servers, we'll look at a diagram in a minute that looks at how everything's tied together. For virtual servers, discovery takes care of connecting the logical server to the ESX. And then we've extended our discovery with how are you going to create these connection points? Because again, we don't want to do this manually. So we leverage serial number matching. The ESX is going to be matched down to a server or blade based upon the discovered serial number in the ESX. And conversely, we have business rules down here. If data center services were to make a hardware repair and have to swap out some of the hardware and change the serial numbers, as soon as you change the serial numbers down here, it's going to automatically look upward and try to find the either non-virtualized Linux, Solaris, or Windows device or the ESX that resides on it. If it can't find one, it ties it to a CI that we titled CI server not found, which gives us the opportunity to go and look at all the data that hasn't been able to appropriately be matched here at the logical layer to the physical layer, and let us sort out, why was there a serial number mismatch? Perhaps there was a piece of equipment that didn't make it into the CMDB, or perhaps there was simply a synchronization timing difference between when discovery ran and when the data updates were made down here. So most of the data in this layer is managed by discovery, or we'll talk a little bit more about our storage data is fed in from, we chose OCI as our source of truth. And then the last piece in our core foundation was the application layer. And this was actually one of the most difficult ones in order to try to sort out. It probably took us a good 6 months to work through the portfolio of applications and to try to ensure that we understood who was going to manage them. This layer, with the exception of the fact that I always represent the data that's associated with the application, so therefore the databases, I put it up here in the business layer. Most of the business layer is going to be manually managed. You can buy tools that will auto-discover pieces of your application in the infrastructure, but it still would be your responsibility to decide how those pieces fit together to represent an enterprise application. Because typically your enterprise architecture and your portfolio management is going to take place at a logical application layer. What are all the bits and pieces pulled together, and what is this application as I represent it to the customers? If anyone uses ServiceNow, you'll kind of recognize this as a really old view of their BSM diagram. I kind of like it better than the one that they have now, but the concept is the same. And I liked it because they represented different classes of data with different colors, made it a little bit easier to see. But I've included this one because it helps understand, create a vision for how things fit together. This one is focused on a Windows server. And it has some discovered components. These are application services that are running on it. This comes from discovery related to the storage that it's discovered. Okay. Our core structure was application to logical server to physical infrastructure. And once we had that core developed, we needed to understand storage. I mentioned that we decided that rather than trying to use ServiceNow's discovery of storage, which we found to be a bit deficient in how it would create this connection between the storage and the logical servers, we decided to integrate with OCI. We are in the process of replacing that now with an integration with Cloud Insight, but the concept is the same. We wanted to represent our storage, and then this tie point here is based upon the storage export. So the storage is exported in OCI to an IP. And since I know what all the IPs are and how they tie back on the ServiceNow side, when I bring this data over, this is a representation of the data from OCI, the clusters, the SVMs, the internal volumes, and these are the exports. I've not tried to represent, everything that this server would have. It would have lots of exports, and it might have file shares versus volume exports. But I've just represented one for the sake of simplicity. This connection is done through automation based upon IP matching. These connections here are made through discovery. So if I discover and use the vCenter discovery, it's going to discover the ESXs. It's going to tell me what virtual machines, along with lots of other things like the clusters and the data stores. It's going to tell me what the virtual machine is, and it's going to automatically tie it together. This magic part right here is what we've done with the serial number matching. So serial number matching is going to get us from the hypervisors to the physical infrastructure. It's going to get us from the storage nodes and storage servers down to the controllers, because at this point I've bridged down into the physical infrastructure. But serial number matching has served us well to be able to create those connections. And then all the rest of the connections are there because Data Center Services is managing this content. The upward connection is the next most often asked question. And I really encourage, as you build a CMDB, to think about data standards and naming conventions. One of the decisions that we made back when we began to build new infrastructure for the data center was that every application would be assigned a contrived three-letter code. And that three-letter code is embedded. Our naming convention for our servers is very succinct. The first three letters tell us if it's virtualized or not. So it's going to start with VMW if it's coming from our vCenter. It's going to have NGZ if it's a Solaris virtualized container, or it's going to have some other codes that tell us that it's really a physical server, a non-virtualized server. But the next three characters are always going to be the three characters that are associated with this particular application. But I have component codes, things like app web and DB that help me understand its purpose. We apply a sequential number, so it's going to have lots of servers for individual applications. And then we always hyphenate our landscape. And hyphenating the landscape, therefore, when I discover this server and ServiceNow Discovery has finished its job, I will then pick apart this name. And if I didn't order this through the service catalog, which when you order the server, you already knew it was for application and NSS, right? But should it have been built in some other fashion, as long as they follow the naming convention, which has allowed us to offer very unique models for certain applications where we couldn't do it through our traditional automation, as long as they follow the naming convention, I can pick it apart and auto-relate this back up to the application. I also know what its landscape and environment are, because I can pick apart the end of the name. This has really significantly helped us ensure that all those lines get connected together through automation. And as we've carried forward into more complex. Now we are looking at hosting cloud-aware applications in Kubernetes environments. And our first foray into that, we didn't really think through naming standards. So we ended up with a cluster with lots and lots of namespaces and pods and containers, and nobody had any idea who owned what. So as we built out our Cloud One program, which provides folks with a fully built out place that they can do DevOps and cloud-aware based development, we've incorporated the 3-letter code into our workspaces, the hosting spaces where you will deploy your stage and production code, and data space environments all end up with the 3-letter code. And that allows me then, when I look at discovering the pods, the services, and the containers, Kubernetes knows what the namespace is that those tie back to. This allows me once again to take that entire complex environment and still know how it relates back to an application. So I mentioned that in my opinion, the key starting point is to build this solid foundation. For us, it was application through a fairly narrow view of the logical infrastructure into the hardware, with a heavy focus on standards and on data ownership. We also had to spend some time with security. I think I have this in my pitfalls as well, is that the standard security model for ServiceNow's CMDB is a bit too open. It really has kind of two roles, one that lets everybody read everything and one that lets everybody write everything. But the reality is that you want, for people who are going to be touching the data, to sort of lock them into the data space that you want them to manage. So we've instantiated roles that provide data center services access to this layer to be able to create relationships between them, but we don't let them up here. This is the space for the operations team, for the storage team, for the network team. They have access to the data here in the logical layer without tampering with and being able to mess with down here. And we have a separate role that we've granted for the SOX team. They're responsible for tagging what part of our infrastructure is officially in scope to SOX compliance and not. So we've kind of partitioned this area up by roles. And then this one was originally role-based, but that's really kind of complicated as applications are registered and as they change ownership. Do you really want to have to grant specific roles? So this is really based upon the data itself. When I register an application, it has a support owner tied to it and a delegate. There's a development owner, program manager, and it's those, if the user's name is in the application profile, then they have the rights to edit it. This has gotten us away from having to create lots of extraneous roles, but it's definitely something to think about in the beginning of your foundation, to think about what groups you're going to have owning the data, and then how you're going to partition them using roles so that they only manage the data that they're responsible for and in fact have access to all of it. And again, a part of our base foundation was some catalogs that allow us to drive hardware provisioning and the creation of CIs in this layer here, as well as a second catalog for your design architecture team. In the beginning, we were not a self-service. Users needed to come to their design architects. The design architects would help them figure out what infrastructure they needed, and then they would place the order. That integration was a ServiceNow laid upon the CMDB and integrated with WFA. The key to maintenance of this layer is really discovery, right? So the catalog is what would typically instantiate something into this layer, and then discovery would keep it up to date. We do two types of scans. We're still heavily dependent upon probe scans. We have a full scan that is integrated with Infoblocks. So every night we pull over the Infoblocks subnets for IT. Those, as I mentioned, are annotated with CMDB data, and they're grouped together by data center into schedules and then we can kick those schedules off. We do a full scan of the entire IT environment every 2 weeks, and then every day, based upon what's in the CMDB, we do a probe scan of all of the known devices. So every device is going to be hit at least once every 24 hours, and then the entire subnet is going to be hit every 2 weeks. We do not run these during our financial blackouts, but we do run them the rest of the time. And then another big piece to building that core foundation before we began to expand was adding discipline here in the application layer. So I think you'll usually find that most IT organizations have sort of a chasm between the application teams and the infrastructure teams. They're usually separate organizations, and the application teams want to know what they run on. The logical servers, the operations team, they want to know who's using the infrastructure. It's really only at this layer that we have named ownership of things, right? This is owned by a group. It's owned by operations. This is owned by a group. It's owned by data center services and their extended team. These, on the other hand, are owned by individual people. And so we did want to wrap a couple of core controls around it. The first was self-service registration. So this is extended off of our enterprise service portal, and it collects all the information that we need from a support prime. They have to register their application before we will build infrastructure for them. And that, of course, is because of our naming convention. I need to know what your 3-letter code is. I don't want to start building infrastructure into the environment and not have a sound set of contact points to come back to. I want to know who owns this from a support perspective. I need to know, is this application, what tier of support is it? Is it customer facing? Is it part of SOX? Is it a part of our financial close process? So all those details are gathered in the registration process, and we don't allow it to be registered unless we have all of that data. Then we maintain the accuracy of it in a couple of different ways. One is we have a quarterly review process. So it sends an email to each support owner, program manager, and a delegate that says it's time for the review. This is something that our internal audit organization does look at to see how many applications are being reviewed. So we actually track that. But the objective is this data needs to be up to date. Let's make sure our contacts are accurate. So if I get a ticket tagged to this application, or I have a problem with this logical infrastructure or the physical infrastructure, I want to be able to bubble up through the relationship tree. I want to be able to get to the applications that are running on it. I need to make sure that I actually have accurate existing contacts. We put controls around transfer of ownership because we found early on that some primes would simply say, well, I don't really have anybody that does anything with that tool anymore. I let some people go. So let me just reassign this to Bob sitting over in the corner. And suddenly Bob discovers he has a new application. So we put controls around this. We use ServiceNow change controls and approvals. So you can initiate the transfer of an application from one person to another because perhaps I'm leaving my position and I want to give that over to another team, or I'm going to leave the company. I can transfer my ownership, and as long as the new owner approves it, then the names will update. The other control that we put in was the leaver process because, just about the time you finally get it all sorted out, who owns what, somebody key leaves. And just like a laptop asset, right? You don't want those assets to go unowned. We need for there to be always a relevant prime that we can tie things back to. So we do have a leaver process when the application owner leaves and their record becomes inactivated. We automatically roll the application ownership to their manager, and that manager gets a notification and has the opportunity to reassign that within their staff or to keep it. But this is one of the things that we do to ensure continuity of ownership so that we don't have any invalid owners up here at the application layer. So let me just pause for a minute. I don't think we had any questions via chat yet, right?
No, not yet.
Okay, so this is what we spent our first year on. Our first year on was importing the data, establishing the standards, deciding how we were going to key this data together and putting into a good discovery process, working on our security and our roles, and then building this registration process because it was hard enough to get this figured out. We sure didn't want it to begin to stray as people started to move between job functions or to leave the company. So this really took us a good solid year to do, at which point, management then immediately began to say, well, this is great, but doesn't have everything in it, right? So it didn't have storage in it at the time. We were dissatisfied with ServiceNow's discovery processes. And so we did do a custom integration with OCI. You saw it on the chart, a couple of charts back. We abstract the assets within OCI and bring those over to ServiceNow CMDB, and then use the IPs from the exports to create connectivity between the storage assets and the CMDB. We also allowed a custom tool called ICE, which is used by data center services to do power and rack visualizations to extract this data and then use it in their planning processes. And we did the CI integration. So these things happened probably within the next 6 months to at maximum a year. One of the key things that we did with configuration CI integration was contain which kinds of CIs could be seen on the incidents and the changes. If you've seen, we could just go back a couple of slides, you'll notice that the CI name discovery adds for a virtual machine instance has the exact same name as the Windows server. And this can create confusion if users make a mistake and are looking at this CI, which is very, very lean, right? Just has basic information. The state of the server is on. It's tied back to this ESX. I think it will tell you what vCenter it's a part of, what its object ID within the vCenter is. And it looks very, very different than when you go look at a discovered Windows server, which is going to tell you everything about it, right? It's going to tell you its IPs and serial numbers, what's installed on it, what model the operating system and the underlying infrastructure, its CPU looks like. So we decided that in order to ensure, I mentioned before that you only want to integrate mature things. So for CI and integration into incident and change management, we purposely limited which CIs could be put into an incident and change so that we could ensure that once they were put in and it walked up the process to identify what the impacted applications were, we were assured it was going to work. And when we didn't have storage in the CMDB, it didn't make sense to allow them to put in pieces of infrastructure that wouldn't be able to walk up the tree at all. We didn't have network, we had network data in there discovering, but we didn't have it tied back to anything. So if I allow you to put that kind of data into the incident and the change, at least in order to trigger the tree walk, right, to find the impacted applications, it generates the wrong impression that you think something great's going to happen when it really didn't. Now we allow users to put into the affected CI section any CI that's in the CMDB, but we make sure that we expose the class and try to educate them. And these have been very useful. You can put in a configuration item. It will tell you which applications are impacted. For change management, you can put in a CI and it will tell you which applications are impacted, and also go ahead and pull from the application profile those users that are going to be your approvers. So lots of other integrations and extensions that we did after that. We've leveraged our data then in Ansible and Xenos for monitoring and configuration management. We extended, you saw on the tree, a layer up. Really in current ServiceNow terminology, this would really be business capabilities, but the capability tables didn't exist at the time, so we leveraged services. And our initial discovery for load balancers was for the F5s. ServiceNow's discovery of F5s and load balancers as a whole is good at providing what are the load balancer services, what are the pools, what are the pool members. But one of the things that it doesn't do is create any connectivity here, and doesn't create any connectivity here. And we did a soft connection here. What it will do is come back and tell you that this pool is comprised of these 5 pool members, and it will tell you what the IPs are. But that's not really telling me, well, what server is that tied back to, and which application then does this load balancer service belong to. So we extended discovery. After discovery is completed, it will run a job, and it will annotate the pool members with that IP belongs to which server. So if you go look at the pools, now you can tell what server it belongs to. And based upon who owns those servers, we then created relationships between the load balancer services and the application. So now the application knows these are all of the servers that I'm running on, and these are all the load balancer services. And again, your key is to use automation, to try not to have people manually touching things and creating these relationships. Otherwise, you're simply not going to be able to maintain them over time. Okay, and then the next big area that we went to is this Cloud One program. So Cloud One within IT really is not a CMDB initiative, but it does sit on top of the CMDB. These were a program to provide self-service, build an entire infrastructure and ecosystem. You can onboard your application, and I will give you everything that you need in order to do cloud-aware application development using DevOps methodologies. So the portal front end is ServiceNow, and all of the elements are going to be represented in the CMDB. The automation itself is owned by a different team, and this environment is actually hosted within Azure. This also gave us the opportunity then to build a self-service portal. Both of these portals are open to everybody in the company. You have to register your application, and then you can onboard it and build, or you can onboard and build infrastructure and load balancers for your individual application and self-service manage them. So this really gave us the opportunity to significantly extend, but use the CMDB as a foundation. So a couple of slides in here that look at what our Cloud One environment looks like. This is our DevOps manage page after you've already onboarded. We leverage, this is going to be a touch point back to the CMDB. You need to be registered. If you've registered, I know who the key primes are for that application. We also import NGs that we tie back to the applications, which extend the security model. And then all the assets that you've provisioned are going to be stored in the CMDB. The backend automation uses APIs into the CMDB to synchronize the inventory that it sees within Azure with the inventory that we see within the CMDB. What's it look like when we look at it with a different model, right? If we look at it from a Kubernetes perspective, as I mentioned, we can discover Kubernetes, and based upon the fact that all these have namespaces, I have the ability to see how this is going to tie back to individual applications. So even in a more complex environment like the Kubernetes, I still have the ability to tie this all back. Same with infrastructure as a service. Infrastructure as a service offers the ability to build and manage VMs, storage, load balancers. Again, security is tied back to the CMDB. We are going to control the name of the host that's provisioned, and that allows us to make sure that we have good CMDB linkages. This data fill is coming from the CMDB also. We are leveraging more cloud. Our current direction is to push more and more into the cloud. And so we are leveraging Spot on NetApp, which leverages excess capacity of vendors like AWS, allows us to acquire, in particular to support sub-production infrastructure on a more cost-effective platform. And then we also implemented smart parking. So the schedules themselves are in the CMDB. and how each server is tied back to a schedule. This basically allows us to turn our infrastructure off on pre-planned schedules. So why have your server up, especially if it's in the cloud, overnight when your developers aren't using it, or over the weekend? The users can use the infrastructure as a service, self-service portal to put their servers into schedules. They can park them over holidays, over extended shutdowns, and therefore we save a significant amount of money. I'm just going to breeze by a couple of these. It's self-evident that any of the storage related things that are ordered are going to be stored in the CMDB. Same with NetApp object storage. Storage grid buckets can be represented in the CMDB in the same way. So I actually just added these last night because it occurred to me that I hadn't really covered quality. You know, one of your 3 prongs for ITIL processes for configuration management, one of them is that you need to have good governance and auditing practices. I kind of divided it into 2. That which is baked in, right? So we have automation around change control in the lever process to ensure my application ownerships are maintained. We have a number of things wrapped around decommissioning. So an application can't be marked decommissioned if it has logical infrastructure beneath it. Physical infrastructure can't be marked decommissioned if it has logical infrastructure that's actually running on it. And then between automation for our Cloud One program and for our original on-prem, very traditional, we have at least some tools that ensure that when an asset leaves the environment, we can do a proper cleanup in the CMDB. We do like to disconnect our logical servers from the application when they're retired. The application owners don't love seeing all that decommissioned infrastructure hanging off their application forever. So creating some just basic automation, mark as decommissioned, ensures that the status changes, a date is captured, all the cleanup, because we don't care to keep all that data that discovery gives us, running processes, et cetera. We go ahead and disconnect and clean that up to keep our CMDB smaller in scope. And this ensures that things are kept clean. And then of course we have automation to ensure that naming conventions are adhered to. So these are kind of the data quality things that are baked in, but then there are other things that we do from an auditing perspective. I run weekly metrics. I look for things that are stuck in the onboarding on order process. I look for applications or servers that have accidentally become disconnected from their applications. And out of 6,000 servers, I think the last time I did this, I had maybe 24 that were primarily appliances and other sort of odd hodgepodgey things that had made it into the inventory. But all of my traditional servers are attached, and it's something that I can easily look at and audit. We look at what percentage of the server base is discovering, and this is going to be on my pitfalls also, because this is a challenge point, right? There's a lot of reasons why servers can stop discovering. They can be turned off, they can be decommissioned without updating the CMDB, they can be behind a firewall, or somebody can simply reconfigure them so they don't discover. So we do watch the level of servers that are discovering. And we also implemented a last status change tracking, because it's really useful in our environment. We have a 2-phase decommissioning. First, we turn it off and see if anything breaks, and then we fully decommission it. And it's really useful to be able to track things like, well, when did it go inactive? So we can go out and search the infrastructure and say, how many have been inactive for more than a month? How about, sadly, how many have been inactive for 6 months? So we can go out and run some programs to do some cleanup. A real-time dashboard that looks at decommissioned servers, inactive servers that are discovering. You wouldn't think that this would happen, but somehow servers aren't really fully decommissioned when they should have been, and they will pop back up. So we will monitor for those. We want to make sure all our SOX servers are discovering continuously, since they're so critical to our compliance. And I continuously monitor security. We have specific rules around who's allowed into the CMDB. In general, if you're in IT, you can have access to it, and if you're not in IT, you cannot. But people move, and so I have a real-time dashboard that lets me look at users that still have the role that lets them in, and I can easily see from that report if they're no longer in IT. So perhaps they've made a lateral move out of IT. Security monitoring is an important thing. We have our full scan reports. I do a quarterly review of relationships to make sure that the core structure, every now and then, some of the manual relationships that get created upside down, or they use the wrong relationship type. This takes me probably a half an hour at this point. And I think the last time I did it, it found 2 things. And that's out of, thousands and thousands of relationships. So it's pretty clean. We have this quarterly application review. It's automated. Every application owner gets a notification. It's time to do the review. We do it in the middle of a financial quarter. We don't like to do it at the start or the end when application owners are involved in the beginning of a financial close or the wrap up from a financial close. So we hit them in the middle. And we do have a report that identifies applications which have rolled overdue. So any application that hasn't been reviewed for a full quarter is going to show up. And we've minimalistically used the out-of-the-box health dashboard that ServiceNow offers. It doesn't offer too many things that I'm really all that enthusiastic about. I do like that it can find orphaned CIs, things that aren't attached downward when they should be or upward when they should be. So that's primarily where we would use it. And I think we would be remiss if we didn't talk a bit about challenges that we've had. So I will confess that we entirely forgot about end-of-life automation. The buildup of our original CMDB, establishing our standards, loading the data, putting a catalog in front of it so that we could provision those new servers. We had the need to be able to move into that new data center rapidly. Kind of forgot about the fact that eventually things start to go away. This has kind of been a pain all along for our on-prem data center because we do have some automation, but we still don't have end-to-end automation because we've focused on, forward-thinking things. The Cloud One program absolutely has end-of-life automation in place. But this is something to not think about because when you're building your CMDB, you kind of forget about the fact that things will go away. And you probably want to think about that earlier rather than later. I've already mentioned that the out-of-the-box security is way too open. So we spent a lot of time locking it down, but then that created a challenge for us. Our first iteration of a self-service portal was a self-service portal for IT only, because depending on how you build your interface, if you give them direct access to the underlying tables, but you don't want those underlying tables exposed to everybody in the entire company, you have a bit of a challenge. So we did have a bit of a challenge coming up with a method for creating portals that allowed us to serve the data to people in the business that are allowed to build servers or build an application, but who are not going to be allowed to have full access to the CMDB. Discovery, everybody, it's like a love-hate relationship, right? It does so much for us, but it's super complex. Monitoring it, and in particular, appliance discovery, is a growing challenge because appliances are very unique and they don't tend to discover particularly well. And then the whole process of how to validate the discovery patterns and probes that we're getting from ServiceNow is just an ongoing challenge. You should be prepared to invest in having some methods to automate whether or not, as you upgrade from release to release, if you're still getting the same data and you're still getting it as accurately. And then probably sort of lastly is reporting. You see that with a ServiceNow CMDB, the structure to get from, say, a physical server up through a blade, through the ESX, through the hypervisor, into the logical server, into the applications, a lot of jumps. And that can make reporting pretty complex. So we have a very large base of reports that are published that we do to help users that answer, we publish them with basic questions like, what is this application hosted on? And then the user just fills in which application. What's hosted on these applications? You can cut and paste in a set of servers, and it's going to come back and tell you which applications are there. I put these down at the bottom, and I see I've misspelled that, so I'll fix it. Adoption of ServiceNow's new CSDM has been challenging, mostly because it doesn't come with really great documentation and models. So we have only adopted pieces and components of it. And this actually is not like a really big pain point for us, because over time, it's really become ingrained that we need to use these standards, and people understand why things unravel if we don't. Okay, as a joke, I was going to put on this slide just the word no. Is the journey ever over? Management comes and says, why do we have to continue investing in the CMDB? Isn't it ever done? And the real answer is it's rarely done, because you're continuously migrating to new technologies. You're continuously incorporating new asset types into your base. We migrated from F5 load balancers to AV. We had to invest in how do you discover those, and are there any differences, which there are, in how you want to represent those and how you want to manage them. And there's always programs within IT to drive cost reductions, automations. You want to automate certificate management or patching or vulnerability management and tracking. All those end up tying back to the CMDB. There's continuous expansion into other data centers. So we always have the need. And I think the real answer is no. You have a really solid core foundation, which you know, you can depend upon. But I think the real answer is no, you're never, ever really done. Okay, so that is the core of my presentation. I see that I used up the bulk of the time. If we've got a couple of questions that we want to go over from chat.
Yeah, can you share a few examples of the most frequently used activities for using the CMDB and logical relationships, e.g. notifying users of upcoming maintenance activity, planning activities for removing applications, chargebacks, capacity planning, etc.
Yeah. So I would, you know, there's a lot of different, let's just go back, I think maybe to this diagram. Come on, keep going. One more. Too far. So being a little unresponsive here. There we go. You know, we have a lot of different user communities. Project managers will tend to use the reports that we published. The two most frequently reports are what's running on this infrastructure. And so they can paste in either pieces here in the storage arena, or they can punch in pieces here from the logical infrastructure. And it will come back and tell you, based upon walking up the relationship tree, what's there. But there's an awful lot of integrations that we've done. Our Xenos integration we've hung some things off, what we call inbound mappings, off of the application CI, URL monitoring. So what URLs do you want to monitor for this application, and where do you want to route it? Are things that we've hung off of this. So Xenos, when it has a notification that it wants to send, can reach over into the CMDB. It can find out what the routing mechanism for that application is. Integration for incident and change management, you know, are key, because when you want to plan a change, you can simply go into the change and key in the things that you intend to touch. And that includes on the Kubernetes side, right? So I can put in the Kubernetes components that I intend to touch, and it will automatically walk up that tree and tell me what's going to be impacted. We don't do chargebacks for anything except public cloud at the moment. And public cloud, we do tagging. We tag everything in the public cloud with a cost center, and we also tag it with a key. Every application, when it's registered, is not only going to have the 3-letter code, which every now and then changes, but is also going to have a unique non-changing key. So we try to tag our cloud assets with that key, so that we can use it for chargeback. But again, that gives us a contact point back, right? We have an application, program manager, and development owner that we can go back to and tag with patching notifications. They will pop in the servers and they can traverse this relationship. We use Splunk for dashboarding. It has some really good application availability and performance metrics, but again, Splunk will pull our data so that it understands the relationship between the logical servers and the applications and has contacts. So it can also build its security off of who is tied back to those applications. Our security team has recently built, I don't know if a data lake is the right term for it, but they're using a database that basically pulls data from all different arenas and aggregates it together. But again, this correlation between logical server and application is critical. So if security identifies a vulnerability, they want to be able to see, having pulled this data over into their tool, they want to be able to see who am I supposed to go back to. So we find this, that's why I said, you know, some of this core stuff that you build as a foundation before you even start expanding out into all this other stuff, this kind of structure right here is just so critical to have right, because you're going to find that you'll leverage it over and over and over again.
Okay. Could you comment on what the minimum end user company size to consider for a CMDB approach in terms of IT resources, services, applications, devices,
Sure.
terabytes, yeah, etc.
Yeah, except for myself, we don't have anybody who is exclusively dedicated. I think the challenge to that question is, what does it take to build it versus what does it take to maintain it? You know, certainly for the original build, we've had to dedicate resources to exclusively to tasks that would build out these things. I don't know that I could aggregate, you know, how many resources we dedicated each time we wanted to do something new, like how did we do this load balancer stuff. But I can say that from an ongoing perspective, we only have myself. We have slices of ops who are responsible for monitoring discovery. But I would not say there's even a full resource within ops who's exclusively dedicated to that. We always have 1 to 2 people in QA that need to have deep CMDB understanding, and we always try to have 2 or 3 resources that really understand the CMDB, understand discovery, but nobody is permanently dedicated to those. We use an agile methodology within our ServiceNow team because we have a number of different instances of ServiceNow. And what you can see from that capability model that I showed, the little eye chart at the beginning, we have a lot of modules implemented within ServiceNow, so we have to share. I don't have any dedicated, permanently dedicated resources for the CMDB itself. My opinion is that most companies will take 6 months to a year to stand this type of thing up, taking into account that you probably want to put automation on top of it. Laying some catalog work on top of it is well worth the effort to ensure that you have the ability. And that we probably had 2 resources dedicated for the better part of that year in order to build that.
And I think you just answered our final question of how many people does IT have to maintain and improve the CMDB?
1 permanent, and then slices of lots of other people, right? Because keep in mind that the key is to get people to own their data, right? This data down here is owned by data center services. I don't audit it, they audit it, right? And they're responsible for maintaining it. So, you know, their job is to maintain the data center and concurrently to maintain the data that goes with it, right? So I don't count them when we think about what's it take to maintain the CMDB. Because they own the data, because they own the resources.
All right. Well, I think that'll bring a close to our webinar today. Everyone will be sending out a recording and the slide deck here shortly. And other than that, Lisa, thank you so much for your time and your insights.
Well, thank you, everybody.
All right, everyone have a wonderful rest of your day.